All right, guys, to help you get ready for the unit exam, I've got two reviews for you. This is review number 1. And what I'm going to do is I'm going to go through and work through just a few of the problems very quickly. I'm not going to work a problem from each simply because, for example, here at Chapter 1, Section 1, goodness gracious, something like that ought to be painfully simple. What I am going to do is go through certain problems that I know have caused problems in the past, whether it be on the test or on the review. And that way, you'll have some idea of what's happening here in terms of the difficult parts. Definitely you want to make sure you look for answers because I will post answers for both reviews. So again, let's get started and we're going to do these very, very quickly. Try to keep the video as short as possible. So take a look. First thing we're going to do is find the distance between these 2 points. And again, over here on the side, they've given examples for you, and then there is the distance formula. So let's work through this one real quick. So I'm going to let A be 0.1 and let B be 0.2. That way we can follow our formula here. So I'm going to take 7, subtract -3. We'll square that result, add it on to, let's see here, 13, subtract 1, square that, and then remember we take the square root of the whole thing. So real quick here, a little reworking of our subtraction just to make it easier. So we've got 10 squared added to, what is that, 12 squared, square root. So we have 100, well, I don't know, we'll drop it over here, I guess. 100 added to 144, take our square root. And then we ultimately find that we're looking for the square root of 244. So what we can do, a couple of things here. First, if you've got a calculator, just type it in and you can get an approximate, there we are, an approximate value for this. If you don't have a calculator, or if you're asked for an exact answer, then what we need to do is try to work through this and see, can we find perfect square numbers that we could use? So let's do that real quick. So I know that 244 is divisible by 4. 4 is a perfect square number. So let's see here. We got 244. We'll do it up here. If I divide it by 4, I know 4 goes into 24 6 times, and then 4 goes into 4, so it'd be 61. 61, unfortunately, is prime, so we're kind of stuck there. So what we'll do is we'll take the square root of this. Square root of 4 is 2, so we have 2 radical 61. So that would be the exact answer, or you could simply type it into your calculator and get a decimal answer. Again, that's approximated. Either way would work. Let's try one of these. In this case, we're looking for the missing end point. So we're not looking for the midpoint, we're looking for the missing end point. So if we were to draw this out, we've got x on one side, we've got y on the other, and m is somewhere in between. As a matter of fact, exactly in between. So one way to find y in this case is to see, for example, from -11 to 15, how far is that, and then continue that same distance on the other side. So I know from -11 all the way up to 15 is 26 in a positive direction. So if I were to take 15 and add another 26, we get 41. So that will be our x-coordinate. And then if we look at the y's, we go from -6 all the way up to 4. That's, again, increase up to 10. So 14 would be our other coordinate. And ta-da, there is y. Let's keep going. Let's see here. 1, 4, this is just naming different things. That should be something you can do without any issues. Let's try 28 for this next one, just to kind of keep our minds open. We've got TVY, so we got TVY, that's this angle here. And what we're trying to do is find an angle supplementary to it. Now notice none of our angles are marked, so we're going to have to go based on what we know, not based on what we see. If we're using TVY, one of the angles that we could name, let's switch colors here, would be here. Notice this is a straight angle, TVY, or excuse me, RVY. So the angle that we could name is angle RVT. That would work. We could also, let's turn our page again, we've got TVY. We could also use this angle here. We could call it, say, WVY. So angle WVY, and that would also work out. So lots of different ways to name it, but again, just wanting to show you there, we're using our eyes in terms of what we know, not, oh, well, this looks like, nope, I know that's a straight angle. There's one side, we just need to grab the other, and we know they're supplementary. All right, let's keep going. For the two-dimensional stuff, I'm not too worried here about your polygon work. Again, just make sure you know the difference between convex, concave, and that you know the difference between regular versus irregular. If you don't know those terms, go look them up. Next, starting into proof here with chapter 2, determine if each conjecture is true or false, and if false, give a counterexample. So let's take a look. If angle 1 and angle 2 are supplementary, all right, cool, so they add up to 180, then angle 1 and angle 2 have to be a linear pair. Well, in this case, this is definitely false. We do not have to have a linear pair for things to be supplementary, and here would be my counterexample. I could say here is angle 1, maybe it's 60 degrees. Here is angle 2 at 120 degrees, and notice they are not a linear pair. They don't have to be adjacent in order to be supplementary. Definitely false. All right, let's keep going. Getting into our logic work. So take a look. Here are the statements we've got. Statement P, a plane contains at least 3 non-collinear points. All right, so I know based on just that single statement that that is true. 3 non-collinear points. So I know this is true, so I'm going to put a T beside it. Q, a square yard is equivalent to 3 square feet. Well, let's think about that, a square yard. So if I were to have a square, and each side is 1 yard, 1 yard. I know a yard is 3 feet, so let's make the conversion, 3 feet, 3 feet. And I were to find that area, 3 times 3 is 9 feet. So 1 squared yard is 9 squared feet. So yeah, this one's definitely false. And then let's go down here. The sum of the measures of 2 complementary angles is 180 degrees. Well, I know the sum of the measures of 2 complementary angles happens to be 90 degrees. So this statement is false. So let's look at a couple of these quick examples just to see if we can figure it out. So not Q. So if I'm looking at not Q, that means this is now a true statement. And R. Well, R is false. So if I've got a true statement and a false statement, well, then the whole statement is false. Remember, for ands, oh, excuse me, that's an or. I'm reading it upside down. Sorry, guys. It would help if I'm looking at it from the right side of the page. This is an or statement. So let's see here. We said not Q. That would be true. And R, we said, was false. So I apologize, folks. This is an or statement. There we go. Don't read them upside down. So in this case, I'm sorry. This would be a true statement. Again, if we've got something that looks like this, like our valley, this is an or. And if we have something that looks like a mountain, this is an and. And again, it helps if you're reading it from the right direction. Tag on. Let's try 15. So this is definitely an and statement. P we said was true. So let's write that down. I know it's true. And let's see, not R. Well, R was false. So that means not R is true. So P and not R, that also is a true statement. All right, very good. But again, folks, be careful. Notice how quickly it was even for me to get screwed up here. You got to read them right. If you don't read them right, it really doesn't matter who you are. You'll be out of luck. All right, let's move on. Conditional statements. So again, we're looking for that truth value. And again, if it's true, wonderful. If it's not, give us a counterexample. Here we go. If you square an integer, so in other words, a positive or negative whole number, then the result is a positive. So let's take a look. I think it's true. And let's try something. If I tried, say, a positive integer, so if I had something like, I don't know, 6 squared. Well, 6 times 6 is 36, so that's positive. It seems to work. Let's try it with a negative. Suppose I have a negative 5 and I square that. Well, negative 5 times negative 5 is 25. So it seems to work. And remember, positive times positive results in a positive answer. Negative times negative is also a positive answer. So definitely a true statement there. Also, make certain that you know the difference, folks, between converse, inverse, and contrapositive. If you don't know those, that could be a real detriment to you on the test. Should be something that you can memorize pretty quickly. Be good to go. Let's see here. Postulates and paragraph proof, not too concerned here. Just make sure you know your postulates. I will not allow you to have any sort of cheat sheet on the test. So you definitely want to have those memorized and known. Let's try a real quick proof here, an algebraic proof. So in this case, our given statement, and that'll go here, given, is that the 6 multiplied by the quantity x subtract 4 is equivalent to 42. We need to prove that x is 3. So we've got a given statement. Our next statement is a distribution slash substitution step. So distributive slash substitution. Again, they're trying to keep it small. That's why they've combined. The next step looks like they have done a quick addition and substitution. So I'm going to write addition slash substitution. And then in this last step, it looks like they've done division slash substitution. So again, it's okay for this. I would have spaced those out a little more, made that proof just a little bit bigger. But again, we're limited for space here, so that's fine. Notice how in this one they've kind of dressed it up a little bit more, tried to spread things out a little bit there. This one, it's a little rough, but it'll work. Moving on. Proving angle relationships. I'm not going to spend a whole lot of time here. They give you a nice sample proof. We've done enough of these that I'd hope you'd be able to go back and look at specific ones and try to pull those out. But, excuse me, let's take a look at an angle relationships proof just to see what we can do. So in this case, we're given these angles, 1, 2, 3, and 4. We know that angle 1 and angle 4 are congruent and that angles 2 and 3 are congruent. Our goal is to take AFC, so AFC, so this angle here, I'm going to try and bold it in for us, is congruent to E, there it is, EFC, so this angle here. So let's get started. First thing I wrote down was my given statement, so that 1 is congruent to 4 and that 2 is congruent to 3. The next statement I'm going to make is that the measure of angle 1 is equal to the measure of angle 4 and that the measure of angle 2 is equal to the measure of angle 3. And I know that based on the definition of what it means to be congruent. Excellent. Well, I noticed that I've got a lot of angles here that should all add together. So my third statement, and I'm going to write it over here just to give myself some space. I didn't realize quite how small I made that. I'm going to say that the measure of angle 1 added to the measure of angle 2 is equivalent to AFC. Measure of angle A. Well, cannot write. AFC. Well, I'm not going to be able to fit there. We'll just go down here. And that the measure of angle 3 added to the measure of angle 4 is equal to the measure of angle EFC. And for that statement, we have the angle addition postulate. Excellent. Now, notice, I know that 1 and 4 are the same. So what I'm going to do here in statement 4 is I'm going to pick one of these, and I'm going to pick the second one for no other reason than I can, and I'm going to take the measure of angle 4 out and put 1 in its place. So the measure of angle 1. And then notice that 2 and 3 are the same. So I'm going to take this out, this 3 out, and put 2 in its place. So the measure of angle 2 plus the measure of angle 1 is equal to the measure of angle EFC. So again, I just took the 3 and the 4 out and substituted. So that will be our reason here. Substitution. Excellent. Well, notice now here in statement 4, in the top of statement 3, measure of angle 1 plus the measure of angle 2, what do you know? They're the same. So I'm going to do another substitution step. Let's see, statement 5, the measure of angle AFC is equal to the measure of angle EFC. And again, another fun substitution step. But notice what we're asked to prove. We're not asked to prove equality, we're asked to prove congruence. So we're going to have one more statement in here. And that, of course, is our proof statement that angle AFC is congruent to angle EFC. And we know that by the definition of congruence. So again, make sure that you're comfortable with your proofs, folks. You need to know your reasons, your postulates, your theorems, your definitions. Got to know that for the test. All right. When we get in here to parallel lines and transversals, this is a lot of you either know it or you don't. So make sure you know corresponding versus alternate interior, etc. You should be fine. For 3-2, pretty much the same story. For example, if we know that angle 1 here is 123 degrees, then it should be pretty simple for us to figure out, for example, that angle 5 is alternate exterior, so it's also 123 degrees. And again, our theorem could be the alternate exterior angle theorem. Or if I'm looking at 14, so 14 is over here, I know that it's going to be the supplement of 123, so that is 57 degrees. And again, I know that based on, well, I know that angle 5 and angle 12 are consecutive, not consecutive, yes, excuse me, consecutive interior angles, and that 12 and 14 would then be vertical. So again, just make sure you know all the terms, how they relate to each other. You should be set. Let's get into, where are we? Here we go. Parallel versus perpendicular versus neither. All right, it's entirely possible that you can end up with something that's not parallel or perpendicular. So I've got AB, all right, that line, and XY, that line, and I need to see if our two lines are parallel, perpendicular or not. So let's take AB first. So if I took 3, so let's see, we'll do this for AB. So if I took 3 subtract 0, remember we do our y's first, over 5 subtract 8, that gives me 3 over negative 3, which is negative 1. So there's our slope for AB. Let's try for XY. So XY's slope is equal to, let's see here, 10, subtract 2, and then 1, subtract negative 7. So let's change that out. That gives me 8 over 8, which is 1. So notice, these are opposite reciprocals of each other. Definitely, we've got perpendicular. If they were identical, then cool, they would be parallel. And if they're not either of those, then neither. Okay? Let's try our equation situation here. So in this case, they want our equation in point slope form. So if we want it in point slope, remember that looks like this. Y subtract y1 equals slope, parentheses, x subtract x1. And there we go. So here's our slope, here's our point. So all we got to do is just plug it in. So for 27, we would have y subtract negative 9 equals our slope, 2, parentheses, x subtract 4. And if it were me, I would clean up this side, the subtracting the negative. That just sort of looks tacky. Again, we could change that out to just a simple addition, and then we're done. We don't have to do anything more than that. If you're going to use slope-intercept forms, that's y equals mx added to b, then in a case like number 29 here, we would have y equals our slope, so in this case 5, x, and then added to our y-intercept, in this case a negative 3, or we could just write subtract 3. Either way, you're golden. Onward and upward, proving lines parallel. Just remember, in this case, we know something about the angles, and that will lead us to whether or not we have a parallel line situation or not. So remember, with these kinds of problems, we can't assume the parallel. We have to know something about the angles first, and then that will let us know something about what we've got on here. So notice, if I have 7 and 10, so here's 7 and 10, and that they are congruent, I have no idea if there is anything parallel here. The only way I would know for certain is if 7 and 10 happen to both be 90-degree angles, in which case, wonderful, then perhaps X and W would work. In this case, since that's all I know, I can't really say that anything is parallel. If I look at 2 and 10 being congruent, well, again, that's good to know, but I would have to know something, say, about 7 or something maybe about 3 in order to allow for that to be truly known. Otherwise, yeah, I don't really know much. So again, be careful with those. They'll get tricky. Perpendiculars and distance. So remember, if we're dealing with anything like this, for example, from L to JK, then I want the perpendicular drawn in, and that will help me get to that distance. Or if I'm looking at, say, from X to VW, I would have to extend VW, and then that would allow me to get that perpendicular that I need. All right. So that is our first review. It's by no means perfect, but it will definitely get you a head start. Remember, you don't have to do it all, okay? Pick the sections that you're struggling with, and you should be good from there. I'll do another video for the second review. It's more test-like, and again, you don't have to do it all. Just work the problems that you need more practice with. Have a good day, guys.